When we want to change a signal's amplitude, we're going to multiply the value of each sample by a number on a linear scale. As an example, if we want our signal to have twice the amplitude, we're going to multiply the value of each sample by 2. If we want our signal to have half the amplitude, we're going to multiply the value of each sample by 0.5. In MATLAB, there are a couple different ways to do this. First, the explicit way to do this is to use a loop, where each time through the loop, we're going to index and iterate through each sample in our signal, and then multiply that element in the array times our scaling factor. Another way to do this is to make use of array operations in MATLAB. Here, if you multiply an individual scalar times an array, it's the equivalent of taking that number and multiplying it by the value of each element in the array. So let's take a look at writing the code to change a signal's amplitude in a couple different ways. Here are two different approaches that we can use to perform a linear gain change on a signal. Now I already went ahead and created an array that we can use as a simple test input signal. This will be good for visualizing the process of changing a signal's amplitude. When I run this script, it's going to take this array and assign it to the variable n. And the next command is to plot a stem plot of this array. So I'll run the script and we can look at the result. Over here in our figure, you see the values for each element in the array. We start at 0, then we have a value of 0.5, 1, and so on. Essentially, we're looking at one cycle of a signal. Now, when we want to change the amplitude of this signal, what we're going to do is go one by one through each element of the array and multiply the value of that element by some number. As an example, let's say we wanted to take this signal and produce a new signal similar to this one but has half the amplitude. The way that this will work is we'll start at the first element and we'll multiply the value here by 0.5. Then we'll move on to the next element, multiply the value here by 0.5, all the way through until we get to the end of the signal. Now, one approach that we can use in MATLAB to do this is to use a loop. So I'm going to go ahead and show you this approach. So we'll say here, method 1, use a loop. Specifically, I'm going to use a for loop. You're going to use the keyword for and then create a new variable here that will count through all the elements of our signal. I'm going to call this variable sample. Say that sample starts at 1 and goes all the way up through the last element, which we have 9 elements in this signal. So I need to put in 9 here. Now I'm going to bracket off the for loop by putting end. Now, each time through the loop, I want to pick out different elements of the array and go sequentially starting from the beginning. So if I want to index the first element of the array as part of the loop, type in input and we'll start at the sample here in the first row in the first column. The next time through, it will move on to the second sample and then the third sample. This is how we can index the elements in our array. Now, as I said before, what we need to do is multiply the value of this sample times some scaling factor. In this example, it's going to be 0.5. What we'll do is we'll take the result of this expression and we'll assign it to a new array, our output array here. And we're also going to index our output array. This way, whenever we're going to take our input sample, we're going to multiply it by 0.5 and create a new array that has the same dimensions, the same size as our input. It just has different values. So now we have the output and it depends on the input. So let's run this script and also visualize the output. So I'll plot another stem plot down here of our output process signal. In order to overlay them on top of each other, I'm going to use this command here, hold on, and then after we're done, we'll say hold off. Now I'll run this script, we can look at the result. So in this case, we now have two signals, one on top of the other one. Our blue signal is our input signal, the original one. Our red one is our processed output signal. The way this works is we take the value of the input and multiply by 0.5. So if our input signal has a value of 1, our output signal has a value of 0.5. If our input signal has a value of minus 0.5, the output has negative 0.25. Let me show you a couple more things that we can add in to this example. Instead of putting in a number here, what I'm going to do is use a variable called amplitude. I'm going to create this variable ahead of time, say amplitude. This is where we could change the amplitude to something else. I'm going to use the value of 2. Run the script again and see what the result is. So in this case, our blue signal is our input and our red signal is our output. Now the output signal has an amplitude that's greater than the input. We multiplied each value by 2, so we end up with a different signal. In general, one good thing to know is that if you multiply by a number on a linear scale that's less than 1, you'll reduce the amplitude of the signal. If you multiply by a number that's greater than 1, you will increase the amplitude of the signal. If you multiply by 1, you get out the same exact signal, 1 times each element in the array. So that's one example here, a visual example for how to do this. Next, let's actually, instead of using this simple input signal, let's use one that we would normally use with audio, or something more similar to what we use with audio. Let's synthesize a sine wave and perform this same processing. So in this case, let's declare some new variables, 48,000 samples per second for our sampling rate, and we can create sampling period. Then we'll create a time vector t that goes from 0 times 0 up to time 1. And we'll transpose this array. Okay, now let's say that f has 3 cycles per second. Now we're going to create our input signal. That's a sine wave, so we can use this kind of syntax that we have used before. In this case, the sine wave is going to be 2 times pi times f times t. Okay, so the last thing we need to adjust is we need to go through sample by sample, not just through the first 9 samples of our signal, but actually based on how many samples we have in our signal. In this case, it's going to end up being 48,001. So 48,001. We can run this and look at the result. Instead of using the stem plot, it will be better for us to visualize just using the regular plot function. So I'm going to change this over to plot. We'll have t against the input, and then also t against the output. Now we're able to look at a sine wave signal where we've changed the amplitude, right? The way this works is each and every individual sample in our signal is still going to be multiplied by that same amplitude value, so that instead of having this signal go from 1 to -1, now it goes to 2 and -2. We can put in any number we want. We could put in a value of 0.88. Run the script again, right? We're going to end up with a signal now that peaks at 0.888. So more examples of how we can use this loop as a way to change the signal's amplitude. Now, besides using a loop, MATLAB, in the way that the syntax works in MATLAB with arrays, allows us to do some other things. So let me go back and make use of this array that we've got here. And just for testing purposes, I'm going to come down to the command window and look at what we've got here. So if this is our array, I'm going to go ahead and look at the result right here. So we've got input and those elements. Before we plotted them, now we can just look at their numbers. So with MATLAB, if we have an array, the way that this works is we can multiply the entire array by a scalar, by an individual number, and that's going to, by default, perform element-wise multiplication. What that means is it goes element by element through and multiplies by that number. So in this case, what I can do is say output is equal to whatever our amplitude is. Let's say that the amplitude is 0.5 times our input. Can run this and look at the result. So if we compare what we had at our input to our output, first value is still 0. Then we have 0.5, 1, and so on. In this case, 0.25, 0.5, and so on. So this is a way that we can actually perform the exact same operation here by using what's called array multiplication by a scalar. So instead of using the loop, let's look at method number 2. Array multiplication. In the first case, we separated out each element of our signal. But now what we're going to do is use the entire array as part of one command. So we'll say the output here is equal to some amplitude times our input. All right, now we're going to plot this signal instead. So I'll comment out this command and then also copy and paste it down here. Let's say that we're going to update the amplitude here to be 0.4. This will help us just make sure that we are visualizing this one instead. So I'll run this script and see what our result is. Our blue is our input signal, our sine wave, and our output is in red. It has a maximum value of 0.4, minimum value of minus 0.4. So now I've demonstrated two different approaches that we can use to change the amplitude of a signal.